Right. Good morning, everyone. Today is Tuesday, October the 5th. We are starting Unit 3 today. We are half done with this course content. All of you should have your midterm exam already finished. That was yesterday, October 4th. You should definitely have Unit 2 done. And guys, double check your Unit 2 quizzes. Make sure everything turned in. So there was a mistake on one of the quizzes. The system gave everybody credit. I don't know what day it was, but if you didn't do one of the quizzes, it automatically gave everyone full points. And I saw that, and so I corrected it yesterday. So double check to make sure you weren't one of the ones that you thought you had the quiz done because it showed a 5 out of 5, but in reality, you didn't. So, and Unit 2 is locking this Sunday, this coming Sunday. Unit 3 is pretty long. It's going to be the entire month of October. This is the conics unit, which we are going to learn about the different conics. Specifically, we're going to learn about circles, ellipses, hyperbolas, and parabolas. And every conic, it looks like it has three lessons, so 3 days. So it's kind of a long unit. This is a unit you really want to stay current with. You know, some of you are in the bad habit of waiting to the last moment, and that's not really a great way to do pre-calc. You probably discovered it's not that easy to procrastinate everything until like the last week. It makes everything very stressful, very difficult, and you know, people that do that, maybe this class isn't for you. So don't forget that if you do not get a C or higher in this class, you will not continue on to next semester. So if you get a D or lower, you will be transferred to a different class next semester. All right, let's get started. Midpoint formula. So we're going to determine the endpoints and midpoints using the formula. Now, this is something that we've all learned, I believe, in geometry. Does that sound right? We did the midpoint, whether algebra 1 or geometry. Yeah, maybe when you see the formula, it'll bring memories back. So make sure you have your paper, pencil, pen out. Take some notes. And we're going to use this midpoint formula to kind of go extra steps. Like it's simple, right? But we're going to kind of do more things with this than just, plug in x sub 1 and x sub 2 and y sub 1, y sub 2. All right, this formula look familiar? You're given like 2 points, like say this point here and this point, and then you use this formula to find the point that is equidistant from this, the same distance from this point to this point. Yeah, it looks familiar, right? So everyone make sure you write this formula down. Don't make the mistake. We are not subtracting. You take the x values and you add them, and then you divide by 2. You take the y values of the 2 coordinates, add them together, and divide by 2. Don't make this mistake. So midpoint, you add and divide by 2. So this should look really familiar. So let's take a look at some examples here. We'll start with ones that are really, really easy. I have the formula on the screen if you didn't have time to write it down from the last one. But what is the midpoint of the points 12, 2 and -3, 5? Now, for when you do these, you should probably label which is which. I say this, and some of you probably will do this, and some of you probably won't. So I like to just, oops, let me, my pen is lagging. X sub 1, Y sub 1, and then X sub 2, and then Y sub 2. Do you think it matters if I call my first set my X sub 1 and Y sub 1 and my second coordinate as X sub 2, Y sub 2? Could I have flip-flopped the naming? Yes, I could have. It doesn't matter. We could have easily have called this X sub 1 and Y sub 1 and this X sub 2 and Y sub 2. Just be consistent. It doesn't matter. I'm doing this because, well, we see it first. So X sub 1, Y sub 1. We see this second, so I call it X sub 2, Y sub 2. That's the only reason why I have them labeled as such. Don't make the mistake. Don't call this X sub 1 and X sub 2, and then don't call this Y sub 1 and Y sub 2, because this is a coordinate, X comma Y, right? All right, so everyone go ahead and plug this stuff into your midpoints and simplify it. I'm going to give all of you, I think, maybe 45 seconds. Should definitely be enough time. 45 seconds. Remember, we do not want decimals. Our answer should never be in decimal form unless the problem originally had decimals to start with. But you need to have simplified fractions if we do have fractions. All right, in chat, what is the coordinate of the midpoint? 9 halves, comma 7 halves. We got 2 people that say that. Anybody else? Nine halves, 7 halves. Anybody else want to agree or disagree? We got 8 people, 7 people here. 3 people responded. Let me ask this question. Are you here? Who's here right now? All right, we got people that are here. Okay. Was 45 seconds not enough time, people? Remember, live sessions, I love it when students participate and give their input, whether they are wrong or they're right. All right, so let's take a look. The answer was 9 halves, comma 7 halves. And, we set it up, right? We have 12 plus negative 3 all over 2, and then we're going to have 2 plus 5 all over 2. So this is why we label stuff. So it's easy to pick out X sub 1 is 12, and then X sub 2 is negative 3. So when you label stuff, there's less thinking needed of which is which. So I really encourage all of you to label your coordinates like I did, because it's much easier to pull these numbers out if you can just see it, right? All right. How are we feeling about using the midpoint formula so far? All right. And don't forget that if I take a little pulse check to see who's here, if I see that you are not here 3 times, maybe 2 or 3 times, I will remove you from the live session. Just keep that in mind if you decide to walk away. And if I remove you, you are able to join right back. So don't feel like if I kick you out, you can't come back. You can. Um, but it looks like I got one person that has been gone twice so far when I asked this question. That's too bad. All right. So, given this problem, the midpoint WX. So remember this symbol means the segment. So the segment WX, the midpoint of that is -3, 4. The coordinates of point X is 7, -2. What is the coordinate of W? All right, so I'd like all of you to write this problem down and then label stuff of what we can. Label stuff. And then once you label it, I want you to set up your equation. Let me give me a green check when you have done those two things. You wrote it down, you labeled the different coordinates, and then you set up the equation. Once you have it set up, just give me a green check so I know that you are ready to go on. If you are unsure about the equation, that's okay. Do what you can. You should write it down, you should label stuff, and if you're not sure about setting up the equation, just do what you can and give me a green check so I know we can go on. Let's wait for one more person. All right, so everyone's ready here. What should I label my 7, -2? What should this be labeled as? I'm going to open up my lesson real quick in PowerPoint. I'm going to make sure what I'm saying matches up to what's underneath that blue. Sometimes what I think now and what I thought when I typed this out are two different things. Okay. Yep. All right. So it looks like a lot of you put x sub 2, y sub 2. And I did the same thing. And I'm guessing that all of you who responded did x sub 1 and x sub 2, y sub 2 because it was second in your line segment, right? So this W would be your first set of points, and this would be your second set of points. So that's was my thinking too, and I'm going to go ahead and label this as such. All right, what did everyone label this coordinate as? Ooh, as the midpoint. Yeah, it is the midpoint. You're right. Yeah, that is the midpoint, right? I'm just maybe just gonna put an M above it or something. All right. So underneath these blue boxes here, we'll start with the easy one. What goes right here? What goes underneath this blue box? -3 comma 4 would be correct. Yeah, because it's the midpoint. It's what it equals. So I give you the midpoint. So we know the equation's going to equal the midpoint, -3 comma 4. All right, let's start with the difficult parts underneath these boxes. Let's do the this segment right here. So in the numerator, what did you write in the numerator? X sub 1 plus 7. Yeah, I agree with you. So it looks like I see some of you wrote the entire term. So I'm going to correct the text. So if you do write it in, from left to right, it should be parentheses x sub 1 plus 7 in parentheses divide by 2. If you don't have the parentheses around the two terms before dividing by 2, you're just telling me you're dividing the 7 by 2. There is a difference. Even though I know what you meant, but that would be the correct way to write it left to right on a keyboard. But remember, on your TGAs, I prefer all of you to do your handwritten work, and I want to see your scratch work. I don't want to see you copy your finished work to paper, because your finished work looks too neat, it looks too clean, and I can't see your scratch work and what your train of thought was. So remember that on TGAs, if I haven't said that before. The TGAs have been looking pretty good so far. I realized when I made those problems, I made number 3 too easy. I don't know if you noticed something about number 3. I'm not going to say it, and please don't say it in chat. But the way the number 3 worked out, I didn't intend for it to do that, and the problem was too easy. So I already uploaded it. People had already done it, so I didn't want to change it and penalize people who didn't do it yet or did do it yet. So number 3 was actually a lot easier than it should have been. Also, number 1 on your TGA, there's more than one way to do RREF, and I see some of you did the way that I did it. Some of you chose to have fractions in your work, and that's okay. It still worked out. And then some of you did a different kind of approach that you didn't have fractions, but it's just a different way that I would have done it, and it's not wrong. So it was nice seeing different ways to do number 1. Number 1 should have been pretty easy. Remember, guys, you get 2 submissions for your TGA. So check out, if you missed anything, check out my comments to make your corrections so you can re-upload. And a lot of you listened to me and uploaded a single PDF with your images full screen, rotated correctly, and it was beautiful. Then there were some of you that uploaded like 3 images sideways, and I'm just wondering why you didn't listen to me. But majority of you actually did it correctly and you put it in a Word document and you saved it as PDF, and it looks really good. Again, guys, when you upload your TGAs, click it to see if it displays. So if you click it and it displays correctly, it means when I click it, it'll display to me correctly. A lot of you, I think, are uploading it and not checking. And when I click it, your document's filled with question marks, like, because it can't convert it because you didn't save it as a PDF. So always double check, because when you go to college or whatever and you have to upload assignments, and if your professor clicks an assignment that they're grading online, like I am here, and they see that it's unreadable or it's corrupted or it's filled with question marks, they're just going to give you a 0 and not contact you. So, I try to treat you all as adults, and you should do better if you're somebody who doesn't check their submissions. Always double check. Anyway, going on back to this problem. Sorry about my tangents. Anyway, underneath this box, we're going to have y1 plus negative 2 all over 2. All right, so who was able to get this equation set up correctly? Good, good. Okay, now here's a question. I'll take a volunteer. To actually solve this, you want to either go on mic, preferably on mic, to try to explain what you would do to solve for x sub 1 and y sub 1. And I can think of really two ways to approach this problem. Noah, please take the mic if you don't mind.
Okay, so I'm thinking because it's a coordinate, then x1 plus 7 over 2, you would set that equal to negative 3. And then same with the second one, y1 plus negative 2 over 2, you'd set that equal to 4.
Perfect. Yeah, that's exactly how you'd want to do it. Nicely done. So, because this is a coordinate, we know that this, whatever this comes out to be, this p should equal negative 3. That's what Noah said. We set it equal to negative 3. And then for the y coordinate, we know that this is going to equal, well, the answer for the y value, which is 4. Very good. Anybody else think about doing that very exact thing? Did you do this in geometry? Did you take the midpoint formula to this, like this far in solving equations? I'm just curious. No, okay. I taught geometry, like I think it was back in 2000, maybe 2010, maybe is the last time I taught geometry. So it's been a while. Um, anyway, so yeah, everyone, go ahead and solve. Go ahead and solve both equations, and then when you solve for your x1 and y1, go ahead and give me a green check so I know that you are done. Remember, if you are done, give me a green check. If you are still working on this problem, give me an X so at least I know you're here. Okay, never mind. Everyone's done. We are good. All right. Everyone together, type in the answer. Don't hit enter yet. Please don't hit enter. So everyone type in what the answer is for the missing coordinate, and then count of 3. Everyone hit enter. 1, 2, 3, enter. Oh, there we go. Only 3 of you. So everyone's done, but only 3 actually answered. Come on. Come on. Is your keyboard broken, everyone? Negative 13 comma 10. So that sounds right, I think. Yeah. But we we multiply. So if you're just kind of curious on what I did, I cleared fractions by multiplying both sides by 2. And then we get this, and then we subtract 7 both sides. So everyone should be able to do a 2-step equation. We did that in probably 7th or 8th grade. Same thing for this one. Multiply both sides by 2, and then add 2 to both sides. So it's a 2-step equation, and we get that. All right, all right. Let's go on to another one. All right, everyone, quickly do this one. I'm going to give all of you a minute and a half to solve this one. Okay, minute and a half. All right, who's done with this problem? Looks like some of you are still working. That's okay. Let me give you some more time. So when you are done with this problem, go ahead and give me a green check so I know that you are done. It's a few of you that are still working. All right, what is the final answer everyone got? -4 comma -5 halves? Ooh, I guess a lot of you could say that. -4 comma -5 halves. All right. Yeah, that sounds right. How can everyone be wrong, right? -4 comma -5 halves. That's what I got as well. Yeah, this is just the midpoint, right? We got x1, y1, x2, y2. Hopefully you labeled yours and then plugged it in, and then you didn't make the mistake of adding 2 negatives together, right? All right, so looks good, everyone. Nice job. All right, let's go on to some harder problems. And yes, this stuff does get a little harder, but not until slide number 9. We're on number 8. All right, so I'm going to give all of you, well, just do this. I'm going to do 2 minutes. We'll do 2 minutes, and then I will check to see who's done. I wish Neuro would have like a built-in timer function. So many things wrong with Neuro. Right. So if you're still working, keep working. If you are done, give me a green check. If you are done, give me a green check. If you're not done, just let me know when you are done. Looks like everyone is finished. So, all right. The question says, what is the other endpoint? So, what is the other endpoint? Go ahead and put your answer in chat. Got -5, 1, -5, 9, -5, 1. Yeah, I think -5, 1 sounds correct. So let's take a look. Yeah, -5, 1. Let's go through it real quick. So there's the initial setup. And again, it doesn't matter if you call this x sub 1, y sub 1, or if you call it x sub 2, y sub 2. I only called it x sub 1. I'm going to write it down. Words are kind of meaningless unless you can see it in math, right? Sometimes. So I called this x sub 1 and I called this y sub 1. And the reason why is because Q appears first in the segment name QR. But if you went ahead and just call that x2, y2, it doesn't matter. Your answer will still be the same. So if you're used to, from the previous example of putting the 5 here and the -5 here and then putting x1 and y1, that's fine. That is totally fine. The setup should be about the same. And then just like last time, you set the respective parts of the coordinate equal to the midpoint part. So the x equals the x, and then the y stuff equals the y. Multiply both sides by 2. And then on the left, we subtracted 5 both sides. And then on one on the right, we added 5 to both sides. And then that's how we get that. So the person who got 9 as the y value, I'm guessing you just forgot to copy the negative in front of the 4. Whether you didn't copy it or you just didn't see it, because when you add 5 to it, I could see why 4 plus 5 would have given you 9 by mistake. So yeah, you just forgot a negative. You just got to be careful not to forget the signs when you copy it down. So again, guys, make sure whenever you see it on your screen and you write in your paper, you write it down, double check to make sure what you wrote matches what's on the screen. It happens so many times that people will miss problems on their, whether it's TGA or your test, where it's fill in the blank because you just didn't copy it right. I had somebody message me in this last test saying, hey, I forgot to copy the negative down, but here's my work. Can I have points? And the answer is no. If you miss a problem, you miss a problem. Like when I taught in person and I graded exams, if your answer was missing a negative sign and your work was pretty good and you just forgot the negative, I marked the entire problem wrong. I don't like giving partial credit. I think either you earn full credits or you get no credit. That's personally how I like to grade. That's probably not how you want to be graded, but that's just how I grade. So you just gotta be careful. But nice job, everyone. All right. Ooh. Let's do a problem with radicals. Dun, dun, dun. All right, let's do 2.5 minutes for this one. Ready, go. Yeah, we only have 2 more examples. We have this one and one more, so we have plenty of time. We got about 17 minutes left before the class ends. Ooh, Alt 251. How cool is that? So if what Rachel says, all you do is hold down the Alt key on your keyboard and type in 251. Also note that you have to use the number pad on your full size keyboard. So if you do Alt and you use the numbers like on the top row of your QWERTY keyboard, it won't work. So you must use the number pad when holding Alt. Alt 251. All right. So if you're done, give me a smiley face. All right. So some of you are not finished yet, but I'm going to go on. Try to finish up real quick, but I am going to just go ahead and go on with this problem. All right, so we got the midpoints. So all of you should have labeled x1, y1, x2, y2, and you should have set it up, right? So we set it up. All right. Who got the setup correct? Who got the setup right? All right. Good. Good, everyone. All right, and then our next step, what did everyone get for the X piece? What is the X piece going to be? It's going to be 4, yeah, because 2 plus 6 is 8, and then 8 divided by 2 is 4. So that was the easy one. Hang on a second, let me try to move stuff. Okay. All right, so we're all in agreement that the X coordinate to the midpoint is 4. Okay, so now the next part. Just talking about the numerator, what is radical 3 plus 3 radical 3 equal to? In the numerator only, what is radical 3 plus 3 radical 3 equal to? 4 radical 3, yes. And you didn't have to type this in to get that. So whenever you are adding or subtracting radicals, they sort of behave like variables. So this is like saying 1x plus 3x. Or if I have 1 apple and then I add 3 more apples, now I'm calling radical 3 an apple. So if we have 1 of these and then we're going to add 3 more to my 1, we have a total of 4. So radical 3 plus 3 radical 3, these are the same radical. So when we add them, you just add the coefficient. So 3 is the coefficient of this radical 3, and then the invisible 1 is the coefficient of this radical 3. Also, if you have a Casio 115, an FX 115 or an FX 300, like what I recommend for this class, and you type that in, it will give you 4 radical 3 as the answer. So guys, if you don't have like a separate calculator, you need to get one. The FX 300 is $10 on Amazon. All right, so we're going to have 4 radical 3 in the numerator. All right, now let's go to the actual simplified answer. What is 4 radical 3 divided by 2? 2 radical 3, yes. And when you divide this, again, you don't need a calculator. I'm hoping all of you know how to simplify a fraction involving radicals. So again, this is like a variable. This is like saying 4x over 2. Well, 2 goes into 4 2 times. So it's 2 radical 3. All right. So who got this final answer correct? Good. Some of you got close, right? Now I encourage you guys, don't limit your knowledge or what you should learn from what you see in this class right now. If you don't understand like a past concept, go on YouTube and search for that concept. Or if you're not really sure, sometimes the struggle is you're not sure what to search for. And I get it. I understand that. Say, hey, Dr. J, I need a refresher on adding and subtracting square roots or radicals or whatever. And I will find you a couple videos that I will pre-screen to make sure they're good, and I will send them to you. So some of you in the past have asked me for that, for past concepts, and that's totally fine. But if you're a little hazy on these past concepts that are not taught in this course, like simplifying or adding radicals or simplifying fractions with radicals, ask me to send you some resources, and I will send you some short videos that I will screen, and you can watch them to hopefully get caught up. But nobody in this class should struggle with doing this math. Okay. All right, my last example. Oh, this one's going to be fun. So we got 9 minutes left. All right, the midpoint of segment YZ is -2, 3. The coordinate of one endpoint is 1/2 x, y minus 2. What is the other endpoint? Ooh, this is a good one. This is more of the pre-calc speed. So let me give all of you 2.5 minutes. Well, we'll say 3 minutes to try to get this one done. A calculator probably won't help you in this problem. Right. So if you think you're done or you are stuck, give me a green check mark. If you are stuck or you think you are done, give me a green check. All right. So people that you either you think you're done or you're stuck. Go ahead and write your final answer in chat, and let's see how you did. It's okay to be wrong. We're gonna figure out what's going on here. So we got x plus 2 comma 2y minus 7. Good effort. Negative 2/3 comma 4. Anybody else? Anybody else? I really want to see what you have or what you think the answer is. 5 comma 7. Anybody else? Negative 4 minus x, 8 minus y. What else we got? Negative 7 halves x comma something. Okay. All right. All right. Anybody else? If you're still working, keep trying to finish it. If you have like the x coordinate done at least, go ahead and just give me that, just like Lamani did. They are, yeah. The answers are all over the place, and that's okay. It's I could see a lot of people missing this question. Nobody's correct, if you're wondering, and that's okay. All right, let's look at the setup first. How much time do we got left? All right, we got 3 minutes. So this setup, what did all of you put for we'll say the numerator? Well, yeah, what'd you get for the numerator on this setup? What's the numerator? Let's see if that's right. So in your setup, what is the numerator going to be? 1/2 x sub 1 plus x sub 2. I like that. Alani, I like what you have. So let's see what I did, and then we'll talk about it. All right. So I went ahead and I made this coordinate my x sub 2, and if you made it your x sub 1, that's fine. Remember, it doesn't matter. I'm going to label this right here is my x sub 1, and I'm sorry, let me backtrack. This right here is my x sub 2, and this right here is my y sub 2. Okay. And we don't know what x sub 1 is, right? That's the other coordinate. So x sub 1, we don't know. And then x sub 2 is just 1/2 x. Okay. We don't know what y sub 1 is. That's what we're trying to solve for. And then y sub 2 is equal to y minus 2. All right. So there's a few ways to simplify this. Like we never want to have a fraction within a fraction, but it's okay for now because, from here, we know the midpoint is -2 comma 3. So we're going to set this piece equal to -2 and this piece equal to 3. But before we do that, who got the setup correct? Whether you used x sub 1 or y or x sub 2, remember, same thing. So who got the setup correct? Okay, good. All right, so we are going to set those pieces equal to, well, their respective midpoint. So we got the x stuff equal the x midpoint answer. We got the y stuff equal the y midpoint answer. All right, and the reason why it doesn't matter if we have a fraction within a fraction, because we're going to clear these fractions right now, right, by multiplying both sides by 2. So it looks like I'm solving 2 equations together. So multiply this one by 2, it clears that fraction on the left. -2 times 2 is -4. On this equation, multiply both sides by 2, clears the fraction on the left, and then 3 times 2 is 6. All right, Nick, remember, our goal is to solve for the other coordinates. So we're trying to solve for x sub 1 and solve for y sub 1. So we want to get everything else to the other side. So what should I do on my equation on the left? What operation should I do? Subtract 1/2 x both sides. Good. So I'm going to just show that work for right now. And we always have the x term first, so we subtract 1/2 x both sides. And we're left with x sub 1 is equal to -1/2 x minus 4. And then on the right, what should I do to solve for y sub 1? What should I do to this side? We're going to add 2 to both sides, and what else? And subtract y both sides. So subtract y both sides and add 2 both sides. I did it in 1 step, I think. Did I do it in 1 step? No, I did it in 2 steps. Normally I would do it in 1 step, but I think I'm just showing extra work. So we add 2 both sides, and then we subtract y both sides. And then we're done. We got to make sure that everything is simplified and combined like terms, which everything is, right? We can't reduce this further. We can't reduce this further. So that means this is the answer. This is your x part, and this is your y part, and we just put it together. Yeah, the problem was still the same. It looked harder because, well, we had variables this time. I would ask who got this one correct, but nobody got it correct. If you did, you probably should have spoke up when I asked for the answer. So hopefully that helps, but we will stop here. Looks like we're 3 minutes over. Well, guys, thanks for coming. And as always, I hope you learned something. I will see you all tomorrow. All right, everyone, take care.